Okay. Grab my geometry book and we'll get started. All right. What lesson are we on today? 1, 2, and 1, 3. And what numbers did we do on 1, 2?
2 through 36.
2 through 36 evens. Number 2 belongs to the rationals and reals. Number 4 belongs to the integers, the rationals, and the reals. Number 6 is the distributive property. Number 8 is the distributive property. Number 10 is -4/9 and then 9/4. 12 is negative square root of 5 and then 1 over the square root of 5, which is an ugly number, but we'll learn more about that later. Number 14 is 23x minus 6y. And 16 is -14c plus 32d. Number 18 is the rationals and the reals. Number 20 is the naturals, the wholes, the integers, the rationals, and also the reals. Number 22 is the natural, whole, integer, rational, and real. 24 is the natural, whole, integer, rationals, and reals. 26 is the additive inverse. 28 is the additive associative property. 30 is 8 and then -1/8. 32 is 0.25 and then -4. Number 34 is 3/8 and then -8/3. 36a is 16 1/4 pounds. 16b, no, 16, that's why I'm confused. 36b, you would have 5 times 2 1/2 plus 3 times 1 1/4. Then you would split that into 5 times the quantity 2 plus 1/2 plus 3 times 1 1/4, which is the definition of a mixed number. Then you would do 5 times 2 plus 5 times 1/2 plus 3 times 1 plus 3 times 1/4, which is distributive property. And then you would do 10 plus 5/2 plus 3 plus 3/4, which is multiplication. Then you would do 10 plus 3 plus 5/2 plus 3/4, which is the commutative property. Then you do 13 plus 5/2 plus 3/4, which is addition. And then you would group into parentheses 13 plus the quantity 5/2 plus 3/4, which is the associative property. And then you would get, 13 plus 3 1/4 or 16 1/4, which is addition. What questions do we have on those?
Can we go over 10?
Yeah. 10 is -4/3. And we want to know what sets he belongs to. Let's get the obvious one out of the way first, right? They're all a member of the real numbers. We haven't even learned about complex numbers yet. Y'all don't even know what that means. Real numbers, great. Is it a rational number? Yes. Yes. What is the check for is it a rational number? So yeah, a positive, negative, but that's not really a test for a rational number because there's other numbers that fit that. Integers also fit that, right? What specifically makes it a rational number?
It's a fraction.
It can be written as a fraction. Great.
I thought 10 is just asking for the additive inverse.
Yeah.
Oh, well, It's a real number. Great. Additive inverse. Great. Easier money. Let's do it something different. Great. I didn't even write the right number down. What was I even looking at? I didn't even know. I was looking at 18. I don't know why I was looking at 18. Let's go back. Just kidding. -4/9. Great. +4/9. Great. The additive inverse. So how do what do that mean?
That means that you have to subtract it by itself.
Yeah, you change the sign. So the additive inverse is -4/9. And then how do we find the multiplicative inverse?
Multiply times itself flipped.
Yeah, so we find the reciprocal. So its multiplicative inverse is 9/4. Whoosh. Safe. What other questions do we have on this lesson?
Can we do 36?
Sure. We can do 36. And what by 36 you mean 36B, right? Or 36A as well? Okay, great. Let's do both. Construction. Did you even try it? Or did you see words and run away screaming? Okay, good. Trust. Okay. George, or possibly Jorge, we don't know, needs 2 different kinds of concrete, quick drying and slow drying. The quick drying concrete mix calls for 2.5 pounds of dry cement, and the slow drying concrete mix calls for 1.25 pounds of dry cement. He needs 5 times more quick drying concrete and 3 times more slow drying concrete than the mix makes. How many pounds of dry cement will he need? So what do we do?
Multiply the 2.5 times 5.
Great, let's start there. 2.5 times 5.
And then 1 1/4 times 3.
So 10 5/2 plus 3 3/4, whatever that is. See if I can beat y'all on your calculators. There's no way 5 3/4 is right. That can't be correct. There's no way that's right. So did I beat y'all on your calculator? Some of y'all weren't even trying. Some of you are just sitting there staring at the world, thinking about your lunch plans. Chick-fil-A isn't that exciting, y'all. Calm down. They don't even bread their chicken right. Open up that Chick-fil-A chicken sandwich next time. Look at the middle of that chicken patty and discover that it doesn't actually really have any breading on it. It does taste good though. I like Chick-fil-A. I'm not a Chick-fil-A hater, but it's not as good as you think it is. You know what company actually makes a better chicken sandwich than Chick-fil-A? Popeyes.
Raising Cane's.
I hope you're joking. No, I like Raising Cane's. I do, but their chicken is like mediocre at best. Is it a 4 or y? Well, I don't know. Where would a y have come from? Okay, we're not quite done yet, right? Because we've got to do part B. Use the properties of real numbers to show how Jorge could compute this amount mentally. Justify each step. Oh, look, I already did that. Sort of. Great. Okay, so set up this. First step. That's like given, right? Something like that. Given this, yes? We call that given, and we won't even rewrite it. All right, wait a minute. Stop, go back, stop doing a proof, stop it. We're done with geometry. Stop it, stop it. Okay, so in order to do this mentally, you need to split this up into a mixed number, right? So that's what I did. I did part of that mentally, right? So we could do 5 times 2 plus 1/2 plus 3 times 1 plus 1/4. What lets us do that? What's the justification? We're going to use distributive property in a minute, but what let me do that one? You're not going to find it in your notes. It's a definition of something. It's not going to be in your notes. It's not going to be there. Definition of a mixed number. That's right. Great. Then what are we going to use? Distributive property, right? So 5 times 2 plus 5 times 1/2 plus 3 times 1 plus 3 times 1/4. Distributive property. Great. Then what would you do?
The additive property.
What additive property?
Well, you add them together.
How? They're not like terms at all. Before we can add anything together, what do we got to do? What comes first? Order of operations. Multiply. So we can multiply, right? 10 plus 5 times 1/2 is what? Why are you doing that? Don't convert it to an ugly decimal. We're trying to do stuff in our head, yo. How about 5/2? How about make it simple? How about KISS method when we can? Keep it simple, silly. Or if you're feeling bold, keep it simple, stupid. Right? What's 5 times 1/2? It's 5/2. What's 3 times 1? 3. Y'all know it's a good day in math class when my voice cracks. It's a good day. What's 3 times 1/4? What?
13/4.
3 times 1 is 3. Right?
Yeah.
So what's 3 times 1/4? 3/4. And y'all may have all said that. I don't even know, but like things happen and we may have got twisted. I don't know. What can we do now? Nah, bro. Which ones do you want to combine first? That's what we're thinking about here. We're trying to think, okay, how can I make this easy? Like if I was doing this, what would I think about? What would I do in my brain first? What would you do first if you were doing this? Combine which ones?
10 and 3.
The 10 and 3 and the 5/2 and 3/4. So we need to rearrange this using a property, right? To where these are together and these are together, right?
Yeah.
Great. Oh yeah, what let us do this, by the way? What let us go from here to here? Multiplication. Good job. We did multiplying. If this was like geometry, we would probably label it substitution or some nonsense, but multiplication is what we did, right? And we can go 10 plus 3 plus 5/2 plus 3/4. What property let us do that? We rearranged it. We moved stuff. This was in the video. This is in your notes.
Transitive?
No, not transitive. Transitive says as if A equals B and B equals C, then A equals C. Right?
Yeah.
Right? So not transitive.
I know what they do, but I can't match the name.
Moving stuff around. I gave a whole analogy in the video and everything.
Is it the associative?
No, not the associative. That's grouping.
Commutative?
Commutative.
Okay, commutating?
It is the commutative. They are commutating.
Well, listen, guys, I did geometry, I swear.
Okay. Then what could we do?
You can add.
We could add. What's 10 plus 3?
13.
13. I was just trying to decide whether they were being a little bit silly with the next couple of steps that they wrote, but. What let us do that?
I think that 10 is supposed to be a 13.
You're right. He identifies as 13.
Good for him. Good for him. Know yourself.
What let us do that?
Addition.
Addition.
Yay.
So what they did next is they did associative and grouped the fractions, and then they combined the fractions, and then they ended up at the end with 16 and a half or whatever by addition. Oh, good. I was looking at the wrong problem. I was like, how did they get 14 and a half? And then I realized I was looking at 50b. Yeah.
I was about to make a reference to a movie no one here has seen. That makes me sad.
Maybe.
Elizabethtown?
No, haven't seen it.
Nope. Sorry.
What does that have to do with 50b?
Well, so 60B is there's a whole scene where he's freaking out about whether he missed the exit 60B.
Ah, it's a whole thing.
I missed 60B. It's great. It's Orlando Bloom before he was lovely.
Oh my gosh. Orlando Bloom is like so silly and overrated.
I'm not saying that because I'm not, like, kiss the ground and walk someone, but like he has a good performance.
When?
In Elizabethtown.
Okay. Well, that does happen because, you're like, you might be like, oh my gosh, Hayden Christensen can't act to save his life, but then you see him in whatever that drama he did after Star Wars. Like, okay, maybe if he's given good writing, maybe he can act. That happens a lot with actors where they're like, you do all this stuff, it's like this person can't act to save them life. It's like Brad Pitt. Brad Pitt plays himself. He plays the cool, hot guy in every movie. You're like, can he act or is he hot? And then you see 12 Monkeys and you're like, oh, okay. He can act. They just have to write a part to let him act. Great. Okay, what other questions do we have? Nothing more on this one? All right, let's do the next one. 1-3, solving equations. Everybody's favorite.
Yay. Yippee.
All right, what numbers did we do? 2 through 28 evens. And we omitted 8. I need to take the omit 8 off of there because that's totally possible for something that y'all could do nowadays. Whatever. Okay, number 2 is 4x minus x squared. Number 4 has different possible answers, of course. Something along the lines of the difference between the square of a number and 9 is 27. Number 6 also has different possible ways to write the answer. 8 more than the quotient of a number and 4 is negative 16 would be one possible way to write it. In case you accidentally did 8, it's the transitive property. Number 10 is negative 6. Number 12 is negative 7. 14 is negative 4. 16 is 8. 18 is negative 5. 20 would be capital P times V over R times T. All that equals N. Number 22 is 4n minus 6. Number 24 is x cubed minus 15. 26 is 4 less than 8 times the number is 16, or something thereabouts. 28 is 3 less than 4 times the square of a number is 3. And what questions do you have on those?
What was the answer to A?
Transitive property.
Can we go over 18?
Sure.
Yeah, that one.
18, that's the one that looks scary but isn't really. But that's all right. We'll dust it.
But I messed it up so bad.
You messed it up so bad. How do you know it was so bad? You probably just made like a mistake.
No, because I put it in a fraction.
Yeah, I know. That still could have been you made just a mistake.
Well, we'll see. We'll find out.
I mean, you could have made the same mistake repeatedly. That happens often. But
Well, okay.
or you could just be an idiot. But I don't teach those very often, so probably not.
Okay.
I teach all kinds of people that say dumb stuff all the time, but that doesn't make you an idiot. Because if that were the case, then I would definitely be an idiot. All right, so we're supposed to solve for m. What should we do?
Distribute the -4 and -6.
Sounds great. Being careful with your negatives. You got to watch your negatives because the negatives are going to explode your life if you're not careful on this problem. There's all kinds of scary negative things that could accidentally ruin everything. What is -4 times 3m?
-12m.
It is -12m. -4 times -10.
40.
-6 times -7m.
+42.
+42m.
42.
What? What is -6 times -6? +36. And then, yeah, where are they?
Then -12
And 42m. And then where else?
40.
40 and 36. What is -12m plus 42m? 30m. I agree. And then what's 40 plus 36?
76.
Oh, yeah.
Now what?
Disc.
Subtract 76. I agree. What is -74 plus -76? -150. And then what?
Divide 30.
Divide the 30. So m equals what? -50. Oh yeah, you're right. Bruh, you led me astray. In the words of the annoying butthole commenter, I'm starting to question your basic math skills. Bruh.
Did someone comment that?
Yeah,
That's crazy.
Yeah. it is crazy.
Also, I just did my maintenance wrong,
I know. That's what I know. I already knew before we started. That's what happened.
Yeah, you knew, but
I said it. Y'all don't like to listen.
I turned 42 to a negative because I forgot.
I turned negative. I turned negative.
I was so confused for half a second because where my brain stopped was I turned 42. I was like, no, I don't think that's accurate. What other questions do we have on this lesson?
Could you
Number 6. Yeah, sure. Write a verbal sentence to represent each equation. X over 4 plus 8 equals something. -16. All right. How about we start with is? All right, that's going to jump from here over there. Look at that. We're already started. We're already trucking. Now what? What do we put over on the right side? Let's start with the easy stuff. Negative 16. Great. Look at us. Look how smart we are. How do we say division in math? Like division? What are you talking about? The quotient sounds great. The quotient of what? And 4. Four. Sounds great. What else could we say? That got us this bit. I can think of a couple different ways to chuck the 8 in there. So it would be tricky to use the sum here because you would have to go the sum of the quotient of a number in 4 and 8. And then you got to figure out, okay, which and goes with which thing, and it gets confusing, right? So using quotient and sum would be possible, but not easily done. If I was going to use that, if I had to use sum, if you said you have to do this problem, you have to use the word sum and quotient, I would say the quotient of the quantity of a number and 4 and 8. So that it gets, okay, there's something that's stuck together, and then we go to this other thing, but that would be a pain in the butt, so we don't want that.
Could we just say added to 8?
Added 8 or just plus 8, right, would be a way we could do it. That would be easy. The way the book does it is probably even cleaner. They say 8 more than the quotient of a number in 4. That's probably even better, but this is fine too. What other questions do we have from this lesson?
Can you go to 20?
Sure. Number 20. How many of you have had chemistry already? You should recognize that formula, just saying.
I do.
You're like, I don't remember what it means, but I do recognize it.
Let me check my toolbox.
Yeah. This is the ideal gas law. PV equals nRT.
Oh yeah, it's from those ones. I don't remember any of those. There's
I don't
too
know
many.
why I made those capitals. That's not right. And we want to solve this for n because it says so, right? So we want to solve for the number of moles. This is a perfect example of when you would use these abstract algebra problems. If you're in science, if you're a scientist, you're whatever, you have this big old ugly formula with all these variables and you want to focus on this one, make the formula be equal to that one. And then it's easy peasy. You shove it into Excel or whatever, and then you move on with your life, right? So we're going to solve this for n. What's attached to n?
RT.
R and the t. How are they attached? Multiplication. How do you get rid of them?
You would division.
You would division them. Sounds great. There you go.
What was the answer to number 16 again?
Answer to number 16 is 8. Sure. I'm sure you just made another negative mistake, but.
I'm positive that I did this up.
Yeah, me too.
Oh.
Pun was not intended until I said it out loud. And then it was.
Yeah, I got it.
Oh wow, wow, that's so nice. That's so great. It's so wonderful.
No, that's what I thought the answer was 80.
Oh.
5 times the quantity, C minus 8 minus 3 times the quantity, 2C plus 12 equals negative 84. So what should we do? Distribute. I'm glad that y'all like respond when I say things. In my geometry class this year, I'm like, what's 2 times 2? And we're like, I sit there for half an hour and then eventually somebody's like, it's 4. Just say words!
I mean, in the last geometry class, we just had the one guy who said stuff.
The one guy.
Reese, yeah, I remember names.
Reese did say stuff until I told him not to say stuff, and then other people said stuff. Did happen. What's 5 times C?
5C.
5C. Reese is in pre-cal this year. He did stuff in a different order, so he had already had algebra 2. What's 5 times negative 8?
I just wrote my numbers down wrong. It's okay, y'all.
Great. Combine like terms. Sounds good. Negative C minus 76 trombones.
Oh, that's what I did.
And then we would add 76. And we get negative C equals negative 8. Divide by negative 1 and get C equals 8.
I just wrote 18 down as
Good job.
That's,
We're very proud.
Thank you.
I
Thank
made
you.
the
I actually worked
opposite
really hard.
positive. That's what I did.
You made the 70. Oh yeah, yeah. Rude.
I would like to thank the Academy, and my mom, and Jesus, and my dog. Yes.
Probably one of those cares about you.
Probably the dog, to be honest. Certainly not the Academy.
Oh. What other questions do we have? Let's take a quiz. John Carpenter submitted late.
I submitted on the wrong ones.
Oh, oops. Hate it when that happens. Quiz 1-3.
Yippee.
Ready, go. You may, in fact, leave once you're done with your quiz. Two concurrent viewers. What's up, people? How's life?